Sir, good evening.
Good evening, everybody.
Welcome.
Good evening.
Thank you. Good evening.
Dr. Smile, good evening. Yeah. Sir, good evening.
Good evening, everybody.
Welcome.
Good evening, sir. Good evening.
Good evening, Indramani Joy. Good evening.
Good evening, sir. Good evening. Welcome.
Good evening. Good evening.
Good evening, sir.
Good evening.
Hi, good evening.
Good evening, Dilip. Good evening, sir. Good evening.
Indramani Joy. Good evening.
Good evening. Good evening. Good evening.
Welcome. Good evening. Good evening.
Good evening, sir.
Hi, good evening.
Good evening, Dilip.
Good evening, sir. Good evening to all.
Good evening. Good evening.
Good evening, Mehta ji.
Dr. C.M. Mehta.
Good evening, Dr. Mehta.
Good evening, sir.
Welcome. This is 7th day. Important one.
Good evening, sir.
Good evening. Good evening, all of you.
Good evening, Vijay.
Good evening, sir.
Good evening. Thank you.
मेहता जी बैठा है सीए डायरेक्टर नीचे देखा है क्या हाँ
Facebook ना
साइड में नहीं है
स्क्रीन शेयर करें
Dr. Indramani Soni has not joined.
I'm asking him.
Please.
He said dot 6 he will be with us, but still I'm
Okay.
reminding.
No problem. Your panel is, if he's going to speak, I think if he comes 2 minutes early, would have been good.
He told me that dot 6 he will be here.
Okay.
So are you online? Oh, please. Thank you. Bumrah sahab.
Yeah, Dr. Peeyush Soni has joined.
Good morning.
Welcome.
Good morning, sir.
Yeah.
Good evening, sir.
Good evening.
Good evening.
Good evening.
sir.
Good evening, Dr. Soni.
Hello.
Good.
Namaskar, sir. Namaskar. कैसे हैं, sir?
Namaskar.
Good evening, sir.
Good
Indramani.
evening, sir.
Good
Yeah, sir.
morning.
Good evening,
morning.
sir.
How are you, Peeyush?
Namaste, sir. Sir, very
नमस्ते,
good.
नमस्ते पीयूष आपने भी दाढ़ी वाला उसमें आ गए आप भी हैं
सर जस्ट फॉर ए चेंज देखिए
अच्छा,
सर
good.
थोड़ा सा कुछ अब वेट तो गेन नहीं हो पा रहा है तो सोच रहे हैं कि सर थोड़ा ऐसे ही जस्ट टू चेंज ओवर द पर्सनैलिटी
ये आजकल ये तो काफी जनरल ट्रेंड हो गया है ना वैसे भी
सर अभी तो वो बड़ा वाला हो रहा है तो वो तो परमिशन नहीं रहती है सर
Okay, good.
सर डॉक्टर सैयद से तो पहली बार मिल रहे हैं आपका नाम बहुत सुना है सर इनफैक्ट आई एम रियली थैंकफुल टू यू एंड प्रोफेसर सिंह एंड इंद्रमणि सर आप सब गुरु के गुरुओं के सामने प्रेजेंट करने का अवसर मिल रहा है आई एम रियली इंडेप्टेड really indebted sir I have been attending all the sessions previously sir they have been very useful sir.
You're very young. Thank you.
Sir, okay, Mehta sir has also joined. Congratulations,
Yeah.
sir.
Thank you. How are you?
Good, sir. Keeping well amidst the
I came
lockdown.
there, but you were not there in office on that day. I tried to meet you.
Oh, probably, sir.
Yeah, I came
Now,
for
in the next opportunity, I will certainly not miss it out. Hope my audio is all right.
Yeah,
sir?
yeah, very clear, very clear. Absolutely no problem.
Okay, sir.
Okay.
No, sir, this has been seriously, it's not just a routine compliment, sir, but it is indeed, I mean, Dil se, sir, this has been very, it's meaningful, sir. It's a small step, but very impactful. There may be topics which we may have forgotten, and it's time to refresh. And when Professor Indramani and of course Professor Singh contacted me, I know in fact it was really an honor for me to join this elite group.
And Peeyush, don't worry. Indramani has plans. It'll be a continuous, ongoing thing. He is planning a lot. Actually, after this, you will know. I think more close contact of ISAE, and the various activities will start. I think that's what he's planning.
Sir, now the environment has also become very conducive for agriculture engineers. From our fraternity, first ever agriculture engineer has become the director, Professor V.K. Tiwari. So this is indeed, perhaps the best time for agriculture engineers, the golden period for agriculture engineers to come from the IIT side, from the IIT system side.
Okay. Thank you. Shall we start, Dr. Indramani?
Yes. Please.
Okay. Thank you, friends, for all. We are meeting on the 7th day. 6 great days are over. And so we have 10 days total of training and lecture. And the last day on 30th, we will have one great session. Okay. Now, I would like today program is Dr. Peeyush Soni. He's associate professor from IIT Kharagpur. And he's going to talk on digital camera applications for a small farm holder, which is actually something like I think it's a very interesting topic because it's the initial part of the big data we are going to have it. Because if we capture every big data contains camera information, whatever images, all this stuff. So this is probably a good one for us to start with. In the meantime, I'll tell you, after this lecture, we are going to have training. We are going to have you review of the whole thing like usual. We'll have probably 10 minutes review of what you have done till now. Because on the context of yesterday's an example what we have shown, many things will come clear what we have talked till now in the training session. Then we'll continue. Today we plan to continue the input output for the controllers. Yesterday we talked up to the controllers. We told examples. We are going to show that. Afterwards, we have input output means that comes sensors, all things. So this will be more of a discussion on sensors. And what will we have another 3 more we can give. So we will end of the session. We'll tell you. We'll talk about protocols and things next 3. Now I would ask Dr. Indramani to introduce the first speaker. Dr. Indramani.
Friends, Professor Singh and friends, this is the 7th successful day. And we have Peeyush Soni today from IIT. But more importantly, another AITians. Peeyush did his BTech from Udaipur, and after that, Masters and PhD from AIT Bangkok. And he was faculty also there, but he has been very much active in AAAE, Asian Association of Agricultural Engineers. I had opportunity to be in AIT at the time of its foundation, and the first conference, which was held in 3 to 6 December 1990, and Professor Singh was at the M of Affairs at that time. So Peeyush, very nice to welcome you, and he has been Secretary General of AAAE. So we are using taking advantage of his experience for ISAE also. He has been honored with number of awards. He is a Science Direct top 25 publication in general Terra Mechanics, and he has been Best Paper Awardee of ISTS Conference, AMA Award, Reddy Award is there, and and he has number of publications. Very promising faculty of IIT Kharagpur. And when we were searching for people who can share their thought and their experience for this webinar, Peeyush, your name came among the top few, and that's how we have shortlisted you. And today you will be presenting your application for smallholder agriculture. As you said, that it has a distinct place-based remote sensing, and as our friend Syed mentioned, that is the start of the big data. So we are very much enthusiastic to listen you. And now I start. Soni, please.
Thank you, sir. Thank you, Professor Indramani, for a very kind introduction. In fact, I feel much embarrassed with these trivial numbers and figures in front of these satellite of gurus. At least at this moment, I feel really honored and much privileged to being invited for this webinar, which I, as earlier mentioned, that and confess that this is indeed a very useful time and product. So without further ado, I will.
Dr. Soni, 1 second. You're comfortable with Zoom? Can we share you? You can computer, or you're not comfortable?
Yes.
We will.
It's all right, sir. It's all right, sir. It's all right.
Setu, sorry, Setu, can you please give him the
sharing is enabled,
share
sir.
option?
Sharing is enabled.
Oh, okay. Thank you. Yeah, please continue.
Right. So I think Vijay will be sharing the presentation.
No, you can share. That's what I asked just now. Whether you are comfortable operating your computer, you run. Okay, no problem.
Either is
no
fine.
Problem.
Either is fine, sir.
No, if you have not done it before. No, if you're not done it
I had done it, but since Vijay is already having, better you can do that, sir, from your end.
Okay, Setu, you must tell to start.
I will, sir. I will, sir. So thank you very much. And as the topic of my webinar today is the digital camera applications for smallholder agriculture. We have seen that the digital cameras, we have very peculiar place in the ground-based remote sensing, and they are relatively inexpensive, and therefore they attract a considerable research interest among the agriculture engineers fraternity. So in this 30-minute webinar, which I consider it very challenging to package some of the interesting features together, I will still try my best to reapprise the audience of the capabilities as well as the limitations, to be fair with the other platforms of digital camera applications in agriculture. Next, please. Now, to set the context, why there is such a hue and cry, and what is the biggest relevance we see for the smallholders, and why they are at the center stage. These two figures are self-explanatory. These are the data which are taken from the Agriculture Research Data Book, which is quite eye-opening, that as high as 67% of our number of operational land holdings are of less than 1 hectare. So the marginal farms are said to be the bottom of the country's agricultural pyramid. And the number of land holdings which are of less than 1 hectare, they constitute more than 2/3 of the national figure. And the land holding pattern, it calls for a smaller mechanization solution. And this is what I took from one of the presentations and speeches of Dr. K.K. Singh. And then I also thank Dr. C.R. Mehta, who rightly said that emerging trends is going to be the cooperative ownership of the model or custom hiring, where the use of high-end equipment is going to prevail, and the affordability of equipment, affordability and equipment size are going to be the key to the success of the Indian agricultural mechanization. Next, please. I take this opportunity to further on what Dr. Shibendu Ray day before yesterday was very kindly mentioning, that we have satellite remote sensing, and he has very clearly explained what are the uses and opportunities lying with the space-based remote sensing platform. So let me go once again a little bit down on the altitude. From the space-based systems, we have the satellites. We have got spatial resolution, the spatial accuracy, and the surface coverages, which are given in the 3 columns which are mentioned here. Then we have the airplane which are running at the higher altitude, and the airplanes at the medium altitude, which are having a medium surface coverage of about 1 kilometer of the range. Then within the airborne platforms, these are the helicopters and the hot air balloons, which have been tried upon on a number of occasions in the US and Canadian system, which have got almost the surface coverage of 1 kilometer. Then at the bottom of this airborne platforms is a drone, which has drawn a considerable amount of attraction in the recent year among the researchers, which has got 0.01 to 0.05 meter of the spatial resolution, which is fantastic, and I think this is workable enough. But it had got the low surface coverage. Now, there are some of the challenges as well as the good things which are lying about these different platforms. Could you please move to the next slide, please? Now, when it comes to choose the platform, the answer to this question is very difficult, because it depends on a number of things. It is similar to choosing a car. It should be an MPV or SUV or something else. So there are lots of criteria, and I can group those important criteria into 2 parts. What is the cost per square meter of using each of the platform? And what is the economic importance of the crop in question, where we are going to apply one of these selected platforms? The ease of operation, the skill requirement, and the other factors, basically the technical factors and generic considerations, they still prevail. But these 2 factors, the cost and the economic importance of the crop in question, I think they play a major role in answering this question, which platform to suggest. The airplanes and the high altitude operations, we have got many free images. They are coming from the space-borne satellites, and they are providing us very clear and stable scenes. and we can also have access to a good amount of historical data. So that is one of the benefits for sure is about the satellite-based remote sensing. Then related to the drones, the good thing about the drones is we can change the sensors. So any low altitude remote sensing platform, which is based on the drones, we can change the sensor type, we can change the camera type. So that is quite handy when it comes to the different types of sensors for us to use. But they have got certain downsides, including, I list the flight time as the first one, because this has been one of the severe limitations. The battery juice drains very quickly, and probably, although their surface coverage is low, furthermore, it is strained with the smaller duration of the flight time. And the next in the line for the constraints of the drone applications, I see that it requires certification to fly. And recently there have been very clear guidelines issued by the DGCA, and they have categorized the drones. And I'm sure that it is not, it is no longer a matter of the kids' play to use the drones and try at their own. The unstable platform, which causes blurred images. This is, well, I should say that this has been one of the major constraints for the users of drone. However, this and the geographic distortion, these two probably have been addressed in the recent research advances to a certain extent. However, the first two, the flight time and the certification issues, they still remain as one of the major bottlenecks for the users of drones in agricultural operations. Then at the ground-based sensors or ground-based platforms, we have got three very prominent options available to choose from. They include the cranes, tripod mount, and the handheld cameras. Before I talk about, or before I try to glorify the camera-based solutions, let me first accept and confess that there are lots of downsides related to the ground-based sensors, which include potentially the single plant or point-based reflectance characteristics. And we should mind that these images are not the ready-to-use image. These are just the images which are carrying certain information, but unless it is processed to an extent, it is becoming useful. It takes a lot of effort behind it. The second downside of using these ground-based sensors, I feel that the localized processing requirement of images is one of those important ones. And given the processing capacity, given the strength of internet available, given the network coverage of internet, I personally see this as one of the limitations. Now, since the entire presentation is going to be based on the good sides of using the camera, so let me come to the business. And I see some of the good sides of using these ground-based platforms, which includes the low cost per square meter of scene captured. And they can be utilized in the plantations, especially where there exists a very dense canopy and there are shaded trees. So the users of these cameras, cranes, and tripods, they have really an edge even over the drones and any other platform above the drones, because from the drone we can only see the view of the canopy from the top, whereas important characteristic information which could otherwise be taken from the camera and other platforms would be missing in those. So there I clearly see an important role for camera-based or a ground platform in this case. Then it is very flexible, and as we understand, and it is relatively easier in terms of its complexity. We will see in later part of my presentation that how easy it would be for any one of us to just play around with that. So I think that this has the potential to be qualified to be suitable for smallholders. Although it is not the inference I would like to make from this presentation, but at least I would like to pose this as one of the potential alternatives for smallholders. Next slide, please. Considering the plantations and their peculiar constraints in being recognized from different sensors, we have these 4 types of arrangement to be made. One is the isometric, the second one is the direct leaf measurement, the third one is the above canopy by using a pole or by a crane, and the last one is the above canopy where UAVs or anything above UAVs can be very helpful. Next, please. The isometric ones, they are providing multi-purpose measurement. We can measure, for example, the diameter of the tree. We can estimate the plant height, given that the reference point or the reference height of the tripod or the crane is known to us. We can find out the leaves, leaf angles, their canopy width, etc. And very clearly and most interestingly, we can reconstruct the object in a 3 dimension, which can be further utilized for various research. We can also find out the gap fraction. The bottom 2 figures, they show the gap fraction obtained from the isometric arrangement of the ground-based solution, and the next figure is the gap fraction from the option C, which is above canopy. The second type of arrangement we can make with these camera-based ground platform is the direct leaf, where we are using an individual leaf for observation. So it is providing us the highest possible resolution among these 4. And its potential applications include anytime using an artificial light source, whereas it has not been that easy for the rest of the 3 methods to provide an artificial lighting source, except for this direct leaf, which is very convenient. And we can conduct the research from the underside of the leaf, which otherwise is very difficult. This system, however, has got some downsides of it, like the single plant or point reflectance characteristics, which is requiring also a localized processing of different images. So this is all about the direct leaf based arrangement. The third one is the above canopy by utilizing the pole. So where the downside is the measurement interference is happening because of the background which is coming in the scene, and this background noise can be sometimes very tricky to be removed, and it will certainly cost us in the reduction of our accuracy. And the final one is the drone. Of course, there are lots of good sides of using the drones, but I see these 2 shortcomings: the accuracy, which depends on the density of the shade trees, and a short flight period per se. Next slide. Before I come to the camera, the digital cameras, which is the focus of my webinar today, let us see what are the different options available in the commercial market. They have been very popular, and I must confess that there is no match of the accuracy at all with the RGB digital cameras. So let us put our feet to the real ground, and we tend to see that what are all those best options available. These are the Volvos, if you like the automobile sector to be analog with. We have got the crop spec. They are using the light source as the laser beam, and it costs about roughly $20,000 to $25,000 US. The next in the series is the Green Seeker, which is from Trimble, and they have got the light source as LED, and it costs about $10,000 to $12,000 for the mounted version, whereas it should cost about $500 to $600 for the handheld version. The handheld version has been quite popularly used in different parts of the world. The third one in the library of commercial product for nitrogen-based estimation is from the Crop Circle, and very interestingly, they have the light source of the modulated polychromatic LEDs, which is very different than the all 4. The last in this series is the Yara N sensor, which is actually the active light source or ALS, and they are using the xenon flash lamp as their light source, and it costs about $20,000 US. Next, please. Now about the cameras. So just a quick refresher of what exactly this camera is and how it captures the information in terms of the light. I am aware that Dr. Said will be taking a full-fledged session on the sensors. However, I take a detour, and very quickly I would like to tell that there is a red, green, and blue, which is measured inside the cameras. And incoming light, the visible part of the light, also the invisible part, which we will be talking later, it passes through the IR blocking filter. Now, this IR blocking filter is something to be remembered that is going to be an interesting practical exercise if anybody would like to do.
Sorry to interrupt, Dr. Soni. You continue explaining about the cameras. I'm not going to explain. Okay, you explain about cameras. Thank you.
Okay, thank you, Dr. Said, for this input. So the incoming light which has passed through the IR blocking filter, this is the filter which actually blocks the infrared component. And infrared, if we have a little understanding about the reflectance, we would definitely relate it with the chlorophyll. As the biomass gets produced with the, as a result of photosynthesis, the chlorophyll is the part of the leaves which actually absorbs the visible part of the spectrum, and the infrared and NIR region is going to be reflected, and this part is actually blocked. So the spectral signature is determined by the presence and or absence of the NIR region in the reflectance. So this is an important filter which we are going to remove actually later on. And there are color filters which control the color light which is reaching to the sensor. And below down there is a main chip. There's a main sensor which includes the millions of light sensors. And this sensor is basically of two types, mainly of two types. One is a CCD and second one is the CMOS. Most of the high definition cameras are fitted with the CMOS, whereas the CCD or the charge coupled device based this image sensor is quite low cost, and most of the webcams are using this CCD. Now the photons which struck the sensor, they are converted into the electrical charges. Now these charges of pixels are read differently. If it is a CCD, then these charges, they get accumulated at the corner of the array, and finally they are converted using an analog to digital conversion into the voltage, which is actually the digital value. And in case of the CMOS sensors, which reads these charges to the individual pixels, for example. Now the next figure is about the traditional film, and which is 4.1 X3 sensor. 4.1 X3 is a direct image sensor, and it is developed by the 4.1 INC, which is now known as the Sigma Corporation, which is one of the major breakthrough and path-breaking research in the color photography. So it uses the array of photosites that consist of the 3 vertically stacked photodiodes, which are organized in 2-dimensional grid. So this is all about what is exactly viewing the information in terms of images, and it is stacked in the 3 bands if we are talking about the RGB digital camera as the red, green, and blue. Next, please. Next slide, please. Now we have talked about the consumer grade cameras, the RGB simple digital cameras. The color band properties which are obtained from the RGB data may not adequately assess the phenological properties of vegetation. The reason is very simple, because most of the vegetative indices like NDVI, GNDVI, etc., well, there are hundreds of that, even more than hundreds of those VIs. They mostly include the NIR. So, but what a consumer grade camera does offer to us which can turn image into information. Now, let us try to see a simple digital camera, which is 200 to 1,200 nanometer sensitivity of its photosensors, probably a CCD base. And unlike the spectrometer and satellites and the other multispectral cameras, only broadband-based vegetative indices can be achieved from this camera. So this is a kind of disappointing information about this camera, but these broadband-based vegetative indices can still be used to assess various important features like chlorophyll, nitrogen, biomass, pest and disease infestation, and the yield. So, and in addition, we can incorporate different sensors in order to augment and enhance the capabilities of these consumer grade information. But at the same time, there are some basic image properties which are stored in the JPEG format, and we will try to make use of those basic properties, which are the RGB information. Now, this is very useful in assessing the color of the object. Obviously, this is all about the colors. It also helps us in computing very basic indices, and these can be augmented and value added later on. So we will keep that information in mind. And we can use this RGB information for recognizing an object or its signature. The next is the date and timestamp, which is very useful if we are trying to integrate different sensors. So a common time is required to create mosaic of information later on. And the next information, which is kind of a default available in all these image properties, which I'm mentioning about the JPEG image format, is the aperture, or the, some people call it as the f-stop. It can be used for the plant or fruit size determination, the plant height and diameter calculation, and the calculation of exposure value. Now, particularly this f-stop, which is highly correlated with the distance between the camera and the object. A change in the focal length, which is automatically taking place if we have set the camera to the automatic mode. So any change in the focal length at the constant imaging distance, we are believing that there is no relative motion between the camera and the object. So the distance between camera and object is the same. Then this change in the focal length is going to change the image scale and the viewing angle. So there are lots of studies available which use linear discriminant analysis, the classifier for object recognition. So this is an important information we can retrieve from a very simple digital RGB camera. Then we have the dimensions about the width and height of the pixel. We can talk about the sum of pixels for the subject as well as the background. So this is very useful information in that accord. Then we have the ISO speed and the exposure time. So these two, along with the f-stop, are going to be very handy for very handy input to calculate the exposure value, which we are going to use later on. Then we have got the additional optional information which we can supplement with the help of other sensors. They will be provided in terms of irradiance, zenith positions, the degree of freedom, and the GPS. So these also can be augmented later on. Next slide, please. Now, if you ever wonder that where is these set of information is stacked, I'm using a Windows operating system, so I took this screenshot. So if you'll just right-click on this image, which is directly taken probably in a raw format, we will find the properties, and if we go to the details tab, we will see lots of information which I have just talked about, including the f-stop, including the exposure time, and if you have utilized a DSLR, it will also talk about the lens type and the lens setting. Next page. Next slide, please. Now, these RGB digital cameras, they have been constrained heavily with the varying daylight condition. So in this research, we proposed, or we actually utilized a method to standardize the index values, which are obtained from a digital RGB camera for assessing the biophysical properties, and the prevailing light conditions were changed. So these improvements actually improved the measurement accuracy. You see, by default, the consumer grade digital camera, it provides the automatic white balance, but each filter has, I'm referring to this RG and B. So each filter has got different transmission characteristics in luminosity. So therefore, it is extremely important the modified cameras have to be customized in terms of the white balance. So we utilize the exposure value, which is a derived variable from the given basic information I showed in the previous slide. We used the exposure value to adjust the digital number and the hue index. So unlike the spectrometer, we can see that there's a spectrometer and there is a spectron, which is perfect white surface. It is not really convenient to all the time white balance using the spectron in the case of digital cameras. So we utilized a camera having a configuration of the auto white balance, auto focus, auto exposure time, and this camera was of 20 megapixel resolution, and the recorded images were in the JPEG format. Next slide, please. So in this slide, I'm going to explain the method we use for adjusting the digital number by factoring in the EV information. Now, this camera, which is providing us as usual the RG and B values, is subjected to the varying light conditions. And the hue index, there's a long formula provided by the Regon et al. In 2016. So this is the hue index, the standard formula. Now, if we add the basic information which we retrieve from the camera JPEG information, which is the f stop, the exposure time, the ISO, and the minimum ISO, we can find out the exposure value as given as 2 log of 2 of the f minus this equation is over there, where the min ISO is representing the minimum ISO setting of the camera. So basically we are taking the ISO to the minimum ISO as a relative measure. Now by utilizing these information, the earlier obtained RGB is now modified with this, I call it as a calibrated DN, respectively for RG and B, and multiplying with the factor of 2 raised to EV. And if we ever wonder that what this EV is denoting, we have got the different digital numbers, and correspondingly we will be using the relative light intensity. And this equation is given if by default these manufacturers, most of the camera manufacturers, they do not provide the gamma characteristics and they do not provide the gamma values. So this equation comes very handy, and we can compute the CDN, or I call it as a calibrated or adjusted digital number, as the alpha times RLI plus beta, and the values of alpha and beta are provided by this particular reference. Now, by using these adjusted values, we can clearly see that the SPAD and nitrogen calculated from the laboratory, the hue and the C hue, which is adjusted C hue, we have got an improvement in the performance. Next slide, please. Next slide, please. Now, in other research, we tried to modify the cameras. Now, we removed the hot mirror. If you recall, in one of the earlier slides, I referred to a filter, which is IR blocking filter. We really did surgically remove it with the help of tweezers, and we used identical cameras. I use this Canon XS160. It is fairly cheap, about 7,000 rupees or so, and we used 2 different types of external filters in addition, so which made it as the NIR-R and NIR-RE. One is the long pass filter, and in second setup we used the red and NIR dual band pass filters, and these external filters costed us about between $100 to $150 each. Now with the help of these external filters, what happened, which is expressed in the bottom left image, which is from the Podol and others studies. The RG and B, including infrared, which is falling onto the image to the camera lens, Now the red and NIR pass filter is there, so NIR is pass. Since we have already removed the IR blockade filter. Now these lights are coming to the micro filters of the R, G, and B. So what we get over here is the red plus NIR, part of the NIR. This is stored in the red channel. So the information which is stored in the red channel is the digital number reading R plus NIR, whereas the G and B channels are now representing the NIR part, the remainder of the NIR part. So the NDVI equation, which is NIR minus R over plus of it, the standard equation, will be now modified for this modified camera use as the NDVI for this CCD or for this camera as V plus G minus R divided by R. Well, there's a caution when we are modifying this camera. Please remember that this is a one-way process, and it should be done absolutely in a dust-free and a dry environment. And mirrorless and DSLRs are really complicated, and I would not personally go for it. And webcams can also be done in the same way, but it requires the magnification. Next slide, please. Now, these are the output received from three of the identical cameras. The red one is the RGB simple camera, without any modification, where the other two are having the long pass filter, the middle one, and the dual pass filter at the right hand side one. The next one, please. Next slide, please. And here are the results from the NIR-R, which is the long pass filter, and the NIR-RE, which is with the dual band pass filter. We were thrilled with the results, which are not that great, but not bad either, and they are really encouraging, finding the R square of minimum R square of 70% or so in both the cases. Next slide, please.
Next one, please.
Dr. Sayed,
Yeah,
how many minutes I may take more?
No, you take another 3 minutes, 4 minutes.
Okay.
Okay for
Thank you.
Okay.
Yes, very much okay. Thank you, Dr. Sayed. So this is another study we did with the cameras. You see, now we have seen using the modified RGB cameras. Now let me give an example of augmenting the RGB cameras with additional sensors. So we have got our simple digital RGB camera, and we use the IMU for finding the degree of freedom and the orientation, and we attached with the pyranometer and a GPS module. Now all these things were attached to an Arduino. Well, it can be anything since we are only triggering an external shutter, so an Arduino was just fine. By the way, Arduino may not be that handy for streaming the video processing. For that, we might need to go for Raspberry Pi or above. Now, these information were utilized to develop an integrated system for monitoring and managing the smallholder coffee and cocoa plantation. Now, a person would simply go on his motorbike and will record the images and augment them with the additional data, and will update the information which can be retrieved anytime with this QR code. But in this, it has been met with certain challenges. The number one challenge was that the assisted GPS or the AGPS enabled mobile phones which were having the median error of about 8 meters or so. So the ground truthing was really a challenge. Then the next one is the internet connectivity, continuity, and the bandwidth. Next slide, please. Well, this is the second last slide. So far, we have seen using the modified RGB cameras, and then we saw how a digital camera can be augmented with the help of additional sensors. Now, let us try to see how the webcam can be used. So in the same way, we modified the webcam. This webcam was quite a simple one. It is not the Logitech one, but it was, I forgot which brand it was, but certainly not the Logitech. So we removed in the same way the hot mirror or the IR blockade filter, And we used this setup since they were quite cheap. So we used 4 of those, and we mounted on the spray boom, which was having the resolution of 1 meter by 1 meter, and we used this boom sprayer at 1.2 meter above the table and inside the greenhouse. And these bottom 4 images show the green color thresholding. The A is showing the plant growth stage determination we use with the segmentation. So the growth of plant can be modeled either with the greenness, or it can be also modeled with the leaf size. So we can use both the shape as well as the size. At the same time, the RGB information to deduce what is going to be the current growth stage of the plant. The bottom 2 figure shows the infested area segmentation for the target detection. So here we use the GNDVI, which is the grain normalized differential vegetation index. So we use this GNDVI to segment the infested part, which are shown in this yellow pixels, and that is where the amount of fertilizer as well as the chemicals they were varied with the help of simple actuator based pumps or so. So I will not go too much detail at that point, but we used a MATLAB for processing these images. Next slide, please. I request go please one by one. So before I start with I call it as a partial conclusions, because the research is ongoing, and we still don't think that we can say with confidence that forget about the other sensors or other platforms and go and use the digital camera. No, this is certainly not the message which ever I would like to convey. The uses of digital cameras in agriculture, they can be explored more potentially by using the information which is provided in the header of each image. I have shown a couple of examples where we could use a simple digital camera to modify the accuracy or to enhance the accuracy, which otherwise would have been not possible. Plantations and the greenhouse application, yes, the digital RGB cameras, they certainly have a very significant edge over any of these platforms. So it is really not a question of or versus. Well, needle is useful at its own place, and the sword is needed at the other place. So with all due regard to the other satellite-based or different sensors, I would like to place the camera and its different versions in this way, that its selection is based on, for the researcher's mind, is mainly based on the technical factors. Whereas when it comes to the farmer's choice, I think their selection is going to be based on the economics, either the economy of these products or the benefit which is translated in terms of the economic benefit, either of those. The next, please. Next, please. Yeah. So there is clearly a need for the lighter processing backend support, lighter so that it can actually support the smartphone. So it should be smartphone friendly to turn the image into an information. Until we get a nationwide free network coverage for agriculture, as Dr. Sayed was mentioning the other day, I think we still need to depend on the smartphones. So here I would like to conclude my webinar, and thank you all for your kind attention. Thank you indeed.
Thank you, Dr. Peeyush Soni. It's a very interesting topic. Personally, you took me to the olden days, my college days, when I purchased a Click 3 and started learning photography. And those days, we were not knowing about gamma corrections, but later on, we come to know when photography technology is improved, we learned about that. You brought a topic which is very hot today and very useful. I'll make a few comments on it before I open it to the other people to ask questions. For example, you talked about the application of Arduino and Raspberry Pi, which we are promoting, people must learn. You talked about GPS, AGPS. You want to find the location where the plant location, we'll talk about. Now come to your camera usage. Many people may not have understood what is NDVI, what is NIR. So for NIR is near infrared, you told already. but don't worry about it. The concept, those who don't understand this, because many youngsters are their engineers, they may not understand all this. This opens your cameras, local cameras of farmers can be used to identify, for example, what is the growth rate, whether any pest infection has come or not, any pest. And plus, if I recall last year in one of the CAST seminars, somebody talked about augmented reality and then virtual reality cameras. So the virtual reality, you see actually a plant with a camera and something like in your eyes. You can see exactly what is the disease it has got. We can forecast something like after 15 days of pest attack. So simply to say, a farmer can have a camera. Now today he's talking about digital camera. Probably your cell phones will have this type of camera in the future. So probably you can have the capacity the farmers can utilize very fast for, especially for finding out diseases and pest management. Now we already had a very good speaker who talked about remote sensing, Dr. S.S. Rai. That is about satellite image camera, also for the agriculture, we learned. Then we also learned from Dr. Manzul Hazarika, who talked about drones to usage. Now we come to down to earth to the normal RGB camera. Actually, professionals, when you talk about the guys who are using like drones or this, they will say always RGB cannot be the best one, whatever it is. But with the limitations, what you told, especially on nitrogen, you can find out, you can find the productivity, and I'm sure it is useful. Leave shape as well as the color information is enough to produce much more information and help to the farmers to grow. And I think, for example, Hazarika told you can use for the drones, you can use even the normal Google Earth software that can give enough information. Probably the people who are listening can work on the camera to find out a lot of applications using the normal low-cost camera. Thank you very much, Dr. Soni. And I would like to ask, yes, I'm seeing some questions. I will put on the question. First, I see Dr. Murthy, please make your question short, so I think he can reply.
Hello, Dr. Peeyush Soni. How are you?
Hi, very good.
Hi, yes.
Please go ahead.
Okay, yeah. So I just had one question. I mean, how easy or difficult is it for us to take the basically the approach that you are trying to do and use it for regular smartphones, for example?
Well, I will say yes, we have done it. We used the Asus Zenfone, which has got Zenfone sensor. But I tell you that I utilized somebody else's camera, a smartphone, which was given to me for play, and I almost broke it. But you know, it is possible. Of course, I wasn't very successful personally doing that, but I got it done through external help. And you are very much right. The smartphones can be modified to respond to the near infrared, part of the near infrared. We call it as a red edge band.
The reason I ask about that is because I mean, with the geo network and all that stuff, now we can basically think of.
We can make questions, sir. Next one, Dr. Narendra Shah has a question. Can you please? Dr. Narendra Shah, you raise your hand. He's not.
Yeah, can you hear me? Can you hear me?
Yes, yes.
So, Peeyush, I mean, for the want of time, I may look a little blunt, but I think we need to go one step further. In the sense, it is good to develop correlations between these RGBs, hues, colors, and because somehow I think in the technology, the small farmer should not get blurred. You connected them through the technology and the small farmer. So if we can go one step further, we have every district in India, there is a KVK. For example, if we can sort of, go ahead and connect and build and demo a model where how we can sort of, you touched a little bit based on cocoa and a coffee farmer. But if we can sort of see that the delta value addition in the farmer's outgo has enhanced because of these correlations, I think it will be really good. But yes, the technology is good.
Thank you. Thank you. We have another question from Madhuri. You can talk now. You can enable your microphone and you can talk. Madhuri? Madhumati, next one. Next question is Madhumati. You can talk. Your mic is enabled. You have to click, unmute your mic, and you can speak. Okay. Next one, can you enable Bhaskar Gaikwad?
Yes.
Yeah, please.
Well, my question is, there are several apps called Bhaikao, then an expert from CRI Katak. They use smartphone, but the question is, there is no generalized algorithm which can characterize each and every mobile phone in the market and give the exact values back. So, so probably that approach is being misutilized. Second is, in the correlations between the modified RGB or RGB to chlorophyll content. So my question to Dr. Soni is, why it is not being compared with the actual NDVI? Because there's a difference between the reflectance spectroscopy and the transmission spectroscopy using the SPAD values. And again, the question is, most of the times,
I think very sorry to interrupt. Very highly technical question. The audience will not. I think.
Just last point to put, sir. Yeah. Last point to put. In majority of the nitrogen application recommendations, where in Indian conditions where farmers apply higher nitrogen, so the chlorophyll values saturate around 300 or so, beyond which these approaches fail.
No, which means
so you the point is,
you want to say this particular technique will fail in certain applications.
It will fail in Indian conditions where excess nitrogen is applied. Yeah.
Okay, thank you. Thank you.
Next,
okay. Next, yeah. Next question, we have more people. Gauri.
Yeah. Hello.
Yeah, please.
Sir, can you
tell
me?
Please.
Yeah. Yes, sir. Hello. Yeah, is it audible?
Yeah. Yeah, it's audible.
Yeah, sir. Can you tell me something about degree of freedom, sir? How to identify degree of freedom in cameras in farm machinery applications? So some DOF point you have raised in that. How to identify the degree of freedom in camera? First question is this, sir. And second one is, sir, what are the alternatives in terms of farm machinery equipments for small scale farmers in terms of precision agriculture, sensor based farming? That I need to know, sir. These two questions.
Second one is not related to this particular camera. I would request Soni to reply both the questions, the previous speaker's question and this question joined together, please.
Okay. So I'll try to summarize this way. You see, in the paucity of time, and what I presented today are not they are just some of the examples. And I'm not going to exaggerate that, this is the total summary of the research. In fact, in my own department at IIT Kharagpur, the senior professors have tried, a lot about these variable rate technologies, and they have utilized the cameras for smart sprayers, for whatnot. And this technology has been applied in the precision farming to an extent that where we can proudly say that yes, now it is a time for us to think how to utilize these off-the-shelf results to the farm. So please don't mistake it this way that this is the only research which I have done. No, this is just a part of the the tip of the iceberg, and lot more has been done within the institute and at the different institutes in the country as well. Now the degree of freedom, there are a concept this which is derived from the mechanical engineering, and perhaps this is why it is raising this confusion. But I was referring to the degree of freedom, the statistic degree of freedom. If we are utilizing the 3 bands and one of the bands is utilized as a function of the other 2, then we are losing the degree of freedom. So I hope that I answered that degree of freedom query, and well, I think this is what I remember so far. Can you repeat the question if it is not answered?
Sir, it is clear. Thank you.
Okay.
Yeah, it's clear, sir. Thank you.
Okay. Thank you, Soni. There is a question from somebody that how soil moisture can be deciphered using RGB. Can you use this camera to find soil moisture level? Short question.
Yeah, this is a very short question, but the answer of this question is immense, and I think this is one of the challenges, research challenges. You see, the soil moisture, the camera only sees the outer side of it. The RGB I'm referring to it. Unless it penetrates, there are images. One is the normal image which is taken from RGB camera, and one is X-ray. So unless there is an X-ray, we really can't talk about what is happening underneath the top top surface. So it is really challenging. I mean, to put it very bluntly.
Thank you. I'm taking from question and answers. So there are some questions. Feasibility of this technology, where you can apply it. This is a question. Can you answer that? Where all you can apply in short form that anybody can understand, not necessarily a technical scientist.
Yeah, for this I will make use. I will take the conclusions which I drew that this is not the technology which I'm daring to refer for all. These are some of the benefits which come along with their own constraints. So some of these methods which I've tried to summarize, they are appearing to me that they are more useful for plantations and for greenhouse applications, whereas the applications are much limited when it comes to the open farm and when it comes to the the cereal crops where the features are totally different. So I'd like to summarize that these are for the plantation crops and for greenhouses to the extent what I presented. But yes, this is not the end. This is not the entire envelope. There are lots of research has been done which they have used the RGB digital cameras for the agricultural purposes.
Thank you. Next question is somebody asked whether you need skilled labor for this.
For removing the hot mirror, no. But I would say that if you don't break your heart, if your 7,000 or 8,000 rupees, this camera which I used was about $100, about 7,000 rupees or so. And I broke one camera, my personal camera. And then the second one, it got succeeded. That's why there were some cautionary tips which I shared that do not open this under a dusty environment, because it's a one-way process. You'll not be able to, it's a destructive process, so you will not be able to put your hot mirror back. And I shared that please do not use mirrorless camera. At least I will not dare to use, because there the hot mirror is present much in a complex manner, and the physical removal is very tricky and difficult. So that's why I stuck to this CCD based camera.
Okay, thank you. One more question is very interesting question is, what type of camera specifications you will recommend for fruit grading and sorting? It's a different application, processing, I mean, after harvesting.
Oh, for grading, I think being an engineer, the solution must be the simplest as yes. possible. So I have seen people have tried even using 2 sticks to grade tomatoes and lemons. So of course it depends on what are the requirements, what are the specifications needed. But I think that the CCD cameras, they have shown their potential in doing so, because they are the shape and the RGB reflectance matters much. If the grading has to be based on the sweetness, then I don't think that the NIR is going to be that helpful.
There are questions like, can you use a camera for killing robots weeding? Yes, of course you can. I think you're not worked on the robot weeding.
No, but in my department, the professors have tried using the cameras for navigation and for all these stuff. So I'm sure that this is doable, and researchers have done it successfully.
And people would like to have the documents for reference, everything. That I think Dr. Indramani, you will talk now, please. Dr. Indramani, please.
No, thank you. Thank you. Dr. Soni, actually, I'm very much pleased and encouraged, with your talk. And I just, the way you connected, I'm taking your last slide and the first slide. The last slide you said comparison between needle and salt and, economy and technicality. And the first slide was that this digital camera technology and smart holder. The kind of situation we are having in this country, I see future of this technology, because this green seeker technology, etc., even farmers level people have started using. So this big thing probably will take time, to come. But this the kind of precision and level of precision we want in Indian agriculture, that also we have to understand. So I'm really very much happy with this talk and the work, and I feel that it should be encouraged and at different centers also. And our fellow researchers like agronomists and soil scientists, they have started, using green seeker and art technology. Now engineering groups should augment their effort, and should join the science behind it and technology behind it, because they are using just as a tool and toy. Many times they are not understanding the basic feature and how we can add and advancement to this technology. Probably the researchers who are engaged in this, should take a note of it. And I feel that this one of the very good talk and very applicable also for Indian condition. Thank you very much for sharing all your thought, and I feel that some other centers should also start working on these things, where full agriculture being is there, like agriculture scientists are there. So together they can make much advancement, and ultimately they can take this technology for farmers use. Thank you very much. This is my brief comment.
Thank you, sir.
Thank you. I just want to add a little bit to Dr. Indramani, what he told just now. 5 years back, I was in Nashik to see some of the irrigation stuff. So there I saw the farmers are having, one farmer is having WhatsApp group. He was having 3 groups. So he told, we don't believe in universities and all giving advice. So we have our own group, and he showed me the photographs. You see, this is what the grapes problem, in that he's asking our opinion. So we all of us do it. So why I want to mention this is this again, in one of the institutes when I visited shortly afterwards, they were designing a website for farmers usage. And I mentioned them, you see, the farmers are using WhatsApp already. There are 3 groups because the people are not enough. So I think they're using the cameras of the same camera, mobile cameras. Only I think probably we scientists must look on how we can help them, probably interpret. Thank you very much. With this comment, anybody, Doctor, anything want to comment now, or lastly, or anybody else?
Yeah, I think the camera photographs are being used very much in insurance of the crop damage, and especially in the disease and pest infestations. So this has been for a long time, but I think with the advances in technology, you definitely help a small farmer, because they don't have to wait for image and where to get it, okay? They take a picture with a smartphone and send it to the agency and get their claims. Yeah. And I'm very happy to see Peeyush again after some time.
Pleasure is mine, sir. Pleasure is indeed mine, sir.